So next we're going to look at these couple of examples. These are from your sheet. So if the clarity on the video, it looks like you can see it, but if the clarity is a little bit off, no big deal. This is just these are the two problems that are on your worksheet, that are on your notes sheet, which you should have in front of you anyway. So anyway, we're talking about the domain. This is putting it all together, looking at everything that we've talked about so far, just in one problem, and we'll do this twice. So first of all, we're going to look at domain. And with the domain of this thing, remember, we're just considering x values. So we've got a hard stop right here at -5. And with a solid dot, that means we are going to include that point. So our domain is going to go from -5. And then we've got this arrow, so it's going to go off forever in that direction. So that's going to be -5 to infinity. So we start off with that -5 to infinity. Our range, that is the y values. And so since this is going down forever, there is -infinity as our beginning for the range of y. So -infinity. And then we go up to this point where we've got 4. So our range is going to be from -infinity up to 4. The zeros are where the thing crosses the axis. So we are crossing the x-axis here, and here, and here. So there are 3 zeros of this function. They are at -1, 0. They are at 1, 0. And at 3, 0. Now we look for relative minimums and relative maximums. It actually makes more sense to look for even though the order is different on the page, we're going to look at the absolutes first. So we've got, as far as minimums go, they are listed in red. Relative minimums, first, is there an absolute minimum? No, because we are going off forever in the negative direction. So that minimum, DNE, that stands for does not exist. I use that abbreviation a lot for things. So if you ever see that DNE, you do not have to write does not exist after that. But DNE stands for does not exist. Now we look for the relative minimums. So those are the bottoms. So we've got one at -4, 2. And then we have another relative minimum at 0, -1. As far as absolute and maximums, we do have this point, which, since it is a point, that is the absolute highest it goes. Remember, if this was not well defined, it would not be a point. We would not have an absolute maximum. But since this is a well-defined point right here, our absolute maximum occurs at the point -5, 4. So we're going to put -5, 4 right there. And then we have relative maximums here and here. So the relative maximums occur at -3, 3. And at the point 2, 1. Next, we have intervals of increase. This is where we are going uphill. So we are going uphill from there to there. And then we are going uphill again from there to there. Remember, when we do this, we do not include the actual endpoints, and we are only looking at x values. So that first one goes from -4 to -3. So our interval of increase would be -4 to -3. That's much better. Then our next unioned with 0 to 2. Now, when we're doing this interval notation, realize that when we it looks a lot like points sometimes, but points are separated by commas. Our interval notation, we are separated here with this U, with this union sign. So that's two intervals. Intervals of decrease, that is where we are going downhill. So we are going downhill from here. We are going down here, and we are going down here. So our decreasing intervals will be from -5, never include the edge point, up to -4, unioned with -3 to 0, unioned with 2 to infinity. Is this a function? It does pass the vertical line test. So yes, it is a function. We find f of 0. So if x is 0, y is -1. F of -2 would be +2. And then f of 5 is -4. So here we have the second problem that was on that page. This is the last example on this. We're looking at domain, that is x values. So we have no left bound on our x. That arrow goes on forever. So our domain is going to go from -infinity. We move right until we get to 4. Notice that there is an open dot at that 4. So we're going to go up to 4. And we're going to use parentheses instead of brackets because we do not want to include the 4. As far as range goes, the lowest point that we get to has a y value of -2. So we will put a bracket with the -2. Then we do have an upgoing arrow, so there is no maximum y value. So we're going to go from 2 up to infinity. We've got a couple of zeros on this function. All right, zeros are where we cross the x-axis. So we are crossing the x-axis here, and then we touch the x-axis there, so that is also a 0. So the three zeros that we have would be -2, 0, comma, 0, 0, comma, 2, 0. So we have 3 points that are zeros. As far as relative minimums go, remember, those are the bottoms of our valleys. So we've got relative minimum here, and here, and here. Before we identify relative minimums, let's go ahead and identify the bottom one, since it is the absolute minimum. We are going to list that here as our absolute minimum, and that will be at the point -1, -2. And so when we go to list our relative minimums, we actually will leave that point out. So our other two are at -5, 3. We have a minimum at -5, 3. And then we have a second relative minimum at the point 2, 0. As far as maximums go, we do not have an absolute maximum because we went off to infinity with our range, but we do have a relative maximum here and a relative maximum there. So the relative maximums occur at -3, 4, and, oops, not a union, comma, 1, 1. The absolute maximum does not exist. Looking at intervals of increase, we are increasing here, and here, and here. So the three red intervals that I've got listed there, that's going to be from -5 to -4, unioned with -1 to +1, unioned with 2 to 4. Decreasing intervals are where we are going down. So that's going to be down there. Oops, that's really close to the same color. So let's switch that to, we'll go to purple. It's nice to have lots of kids because I just have more markers than I know what to deal with. So I'm going down there, I'm going down there, and then I'm going down there. So I've got 3. My intervals of decreasing intervals, that's going to go from -infinity to -5, unioned with -4 to -1, unioned with 1 to 2. This is a function. F of 0 is 0. F of -2 is also 0, and f of 5 does not exist because the function actually stopped at 4. All right, that's a day. Have a great afternoon and evening. See you later. Goodbye.